In this video, I am going to go through laws of logarithms. So here's the first law. It says if you have log x multiplying y multiplying z to base a is equals to the same as log y base a plus log x base a plus log z base a. So here's an example. Log 12 times 5 times 9 base 3. So according to the first law, can be written as log 12 base 3 plus log 5 base 3 plus log 9 base 3. So something to notice here is that the base is the same throughout the equation. So here's the second law. It says if you have in the first law, the reverse is true for this case. So if you have, for example, log 6 base 5 plus log 12 base 5, this can be written as log 6 times 12 base 5, and 6 times 12, that's 72. So this will be log 72 base 5. So the second law says if you have, it's the same as the first law, but in this case, instead of multiplication, it's a division sign here. So it says log y over z base a is the same as log y base a minus log z base a. So the numerator minus the denominator, log of the numerator minus log of the denominator. So here's an example. We have log 3 over 2 base 5. So according to the second law, you can write this as log of the numerator is 3 base 5 minus log of the denominator, that's 2 base 5. So that's the second law. Moving on to the third law, it says if you have something like this, log y power m base b can be written as the power multiplying the log y without the power base b. So here's an example for to understand this. Log 7 squared power 9. So according to this law, can be written as the power, that's 2 in bracket log 7 without the power again base 9, and this can be, the bracket can be cleared out, and this will just be 2 log 7 base 9. So that's third law. The fourth law says if you have log c base c, that's equals to 1. So no matter what the number is, as long as this number is the same as the base, the log number is the same as the base, it will result into a 1. And it makes sense because this can be written back to its index form as the base, that's c, power this number 1 is equals to this c, and it makes sense because c power 1, that's c. So here's an example. Log 4 base 4, that's equals to 1 according to this law, and it makes sense because 4 power 1 is the same as just 4. So moving on, the fifth law says if you have log 1 over z base a, that's nothing but negative log z base a. So here's, in this case, that's 1 over z, and in the left hand side of the equation is 1 over z, but in the right hand side, that's negative, then that's just a z, not a 1 over z anymore. So it's an example. Log 1 over 3 base 6, according to this law, can be written as negative log 1 over 3. So let's check how this works. 1 over 3 can be written as 3 power negative 1. So you can use the law we have learned before about the powers multiplying the log. So this can be written as log base 6 1 over 3, that's 3 power minus 1, and this is nothing but we will multiply the 1 minus 1 into log 3 base 6, and by clearing out the bracket we just get minus log 3 base 6 so that's how we got the law. And the final law here in this video says log 1 base A is equal to 0, log 1 base B is also equal to 0, log 1 base C is 0. So no matter what the base, as long as it's a log 1, so it will result into a 0, and it makes sense also because writing this in its index form, we get this A power, the number on the other opposite side, that's 0, will be equals to this one. You know, any number power 0, that's 1. Also here B power 0 is also equals to 1. Here also C power number on the opposite side 0, that's equals to 1 also. So it's an example. Log 1 base 3, that's equals to 0 also because 3 power 0 is equals to 1. Log 1 base 10, that's also equals to 0 because 10 power 0 is also equals to 1.